Okay, so yes, a presentation on fast regularized pet reconstruction with stochastic averaging and an Armijo line search. So we went into this with a motivation to demonstrate the performance of some out-the-box stochastic algorithms with just some small additions to account for the differences in data. So we looked at two algorithms that you can get straight from SIL, so SVRG and Saga. And we set them up in pretty much the same way. So we had a warm start to both algorithms. We chose the step size using an Armijo line search, and also had a reduction in our step size. We used the same preconditioner, BSREM preconditioner, which you've heard a bit about today. And then we had a subset selection strategy according to how many counts we had per subset, and ensured there weren't too many subsets for each set of data. So the only differences between the algorithm were obviously the way the algorithms work, but we initialized our Saga with a full gradient update, and then Saga, as you've heard, updates its gradients as it's going. And with SVRG, we updated the full gradient each epoch, which turned out to be a bit of a mistake. So stochastic optimization, if we're wanting to optimize an objective function which is made up of our data fidelity function plus a regularizer, and we're looking to minimize this, and so we can do this by gradient descent, but this turns out to be very slow for pet reconstruction because we've got this big forward model which we have to evaluate every single iteration. And so we split our objective function into subsets, and then we take subset gradients, but this can be very noisy, this descent direction. So we turn to some variance reduction methods. So you've heard both of these today. Saga refreshes subgradients using the most recent subgradient, and SVRG takes an anchor image which is updated periodically, and the gradient estimate is made up of your current subset, previous subset gradient, and this whole gradient from this anchor image. We used a BSREM preconditioner, again, like Robbie used in his paper. So this is the current image divided by the sum of the sensitivity images for all your different subsets. And down here below, you can see just an example of what the BSREM preconditioner looks like compared to the current image with which that preconditioner is calculated. So very similar. And we found that I'll start here, sorry, these are in the wrong order. So in order to choose our step size, we used an Armijo step size selection. So you start with quite a high step size, and then you see whether this here is satisfied. And if this isn't satisfied, then you reduce the step size until the descent is great enough that you're happy, and then you continue, and that's what you set for your step size for that iteration. So we found that if you calculated an Armijo step size for your first gradient and decided to use that for the rest of your reconstruction, it was often too high, and you ended up with divergence. So we decided to warm start our algorithm with 5 iterations of gradient descent using an Armijo step size, and then we'd use the minimum step size during these 5 iterations as our step size for the rest of the algorithm. And then that was reduced as a function of your number of iterations as well. We chose our subsets so that the minimum counts for each subset must be at least 2 to the 20, and this was just found empirically. We decided that the subsets can't be more than a quarter of the number of views. We said the maximum number of subsets had to be 32, and that the subsets must be of equal size. So with an equal number of views for each subset. And this resulted in subsets ranging between 10 and 32, depending on the different types of data. So these are some of our results. We saw that Saga was generally faster, but much noisier, and SVRG, and that was primarily because it was able to take many more steps. So you can see for the top For the top graph here, there were 97 steps for Saga compared to 47 for SVRG, and for the bottom, 161 compared to 71, with quite similar drops in root mean square error. But Saga was just able to take more iterations and so got further. And so this might have been because we decided to update our full gradient each epoch rather than every 2 epochs, as is often seen in literature. So Saga was noisier, faster, but often unstable. So for some of the smaller VOIs, SVRG stability was sometimes beneficial. So you can see here, this is for a small hot cylinder in one of the bits of data, and Saga is all over the place towards the end, whereas SVRG manages to descend very stably. We also noticed that because probably our preconditioner wasn't very optimal, the step size varied massively. And this meant that when we got to the test data, we found that our highest step size, which we'd chosen based on the training data, was far too low. And so we got a really, really poor result for some of our algorithms, where we didn't make any progress whatsoever for the whole hour that we ran our algorithm for. So the preconditioner that we use is designed solely for the data term, but it does perform quite well in some cases, and this is where we managed to get quite quick convergence. And I don't know how easy this is to see, but we're comparing the BSREM preconditioner here to the diagonals, the inverse diagonals of the Hessian for the prior term. And you can see that when our algorithm performed quite well, they were very similar, even towards convergence. But when we performed poorly, the BSREM preconditioner was very, very different to this, to the diagonals of our inverse Hessian. So even for very similar phantoms, we saw this was the case. So at the top, we've got quite a high count Hoffman phantom. At the bottom, quite a low count Hoffman phantom. And you can see that the BSREM preconditioner is very, very far from optimal, especially towards the end of our algorithm. So what have I learned from this? Firstly, I think, like Georg and his team did, it's really important to include your prior in your preconditioner. Otherwise, you can struggle towards the end of your reconstruction. Different data can require very, very different step size choices if you do decide to use the BSREM preconditioner. Also, that updating every epoch with SVRG is a bad idea. It can really slow down your progress. Most literature suggests 2 epochs, but it's probably a good idea to vary the interval and have larger intervals in later stages where your gradient is more stable. And that Saga's instability can cause issues, so it's something to look out for. Thanks very much for listening. Any questions?